Let's go over a little bit of algebra for you. Remember, in algebra, you learned about a line, y equals to mx plus b. Any number multiplied by x plus b represents a linear equation. So this is a linear equation. So as you remember, we introduced m to be slope of the line, slope or rate of change. We talk about x as a free variable. Free variable or independent variable, right? Y depends on x. Dependent variable. And as you remember, b is called the y-intercept. Sometimes you have a nice mathematical model which represents a linear relation between x and y. For example, y equals to 2x plus 5. You might end up seeing some equations that have negative slope, like y equals to minus 3x plus 1. These are what we saw before. These are mathematical model that we have. Mathematical model. And based on the slope of the line, we learned how to analyze the behavior of the line. For example, we saw that if m for the slope is positive, then we expect to see a graph as increasing graph. So here you have your x-axis, and here you have your y-axis, right? So the graph behaves like this. The graph goes up from left to right. So remember, you always read graphs from left to right. It's uphill. It is increasing. Uphill. So in this scenario, we say that as x approaches to larger values, as x increases, my y increases as well. As x increases, y increases as well. However, if you have a negative slope, if m is less than 0, like this case, this scenario, you have a negative slope. We expect the graph to be a decreasing graph. Decreasing graph. X and y. So we have a graph from left to right, the graph starts decreasing, all right? So again, from left to right, the graph is decreasing downhill. So here we have downhill graph, all right? So as x increases and as x goes to more larger numbers, my y starts decreasing. So you're going to say as x increases, y decreases, y goes down. So again, sometimes you have a nice mathematical relation between two variables like x and y. Some other times, especially in statistics, we see a lot of information about x and the y as two variables that we don't get the exact same nice line that you see here. Instead, we get a bunch of points. So for example, in statistics, instead of seeing these nice lines, we have some x and y, and then we have a bunch of points. These points are just right here. Then in statistics, we use the regression line to find the best fitted line for these values. There are actually difference between the actual y values and the predicted y values of the linear regression line here. We call those residuals. So when you're using statistical techniques to analyze the behavior of these points, X and Y's, you have another element that is very useful, R, or the correlation coefficient. It helps us to understand how X and Y's are actually related together. What is the association between them? As long as R is equal to 1, we have a perfect positive correlation. If R is around 80%, then we have a strong positive correlation. A strong positive correlation. But if R is getting smaller than these, then we say that we have a weak positive correlation. So for example, you might see here the X value might be the number of hours a student studying for exams. And here you can associate Y to, for example, exam score itself, the number of hours the students are studying and the score they are getting. Number of hours of studying. And then Y might be the GPA or exam score, right? Some other times you have a bunch of points that might not be related at all, or you see a weak correlation between them. For example, if you have some points here behaving like this, you see you have a lot of noise that you cannot just ignore. For example, the number of cups of coffees that students drink in every day and their GPA. Coffee and GPA. And we don't expect to see a very good correlation between these data. And you might see something like this in statistics as well. You might see a decreasing trend like this. Well, the correlation is negative in this case. The regression line is decreasing line. For example, the miles on a car and the price of the car. As the number of miles, as the miles increases, the price decreases. We expect that. So as you can see here, you have a negative correlation between the data. So these points, they are representing scatter plots. You have X and you have Y. You have a couple of points and you plot those in XY plane, connect them together, and you have a regression line. These are all examples of scatter plots.